Welcome to today's Explainer. You know, have you ever watched a master chef meticulously prepare a world-class dish? Think about it. They don't just grab a bunch of raw ingredients, throw them into a pan, turn up the heat, and just hope for the best. Absolutely not. They follow a precise, carefully practiced recipe of preparation, execution, and finally, presentation. Well, I want you to adopt that exact same mindset today, because mastering the Cambridge Mathematics Syllabus 9709, and specifically the notoriously difficult topic 4.4, Newton's laws of motion on inclined planes, is exactly the same process. To pull off an A-star performance, you need a perfect recipe. You need your evidence, which are your raw mathematical ingredients, you need your analysis, which is your actual cooking process, and you need your evaluation, which is your final, beautiful plating for the examiner. Today, we are going to transform you into that mathematical master chef. We're going to completely deconstruct the exact strategies that separate the top-tier candidates from everyone else. So get ready to change how you look at exam papers forever.
Now, to prove just how absolutely crucial this mindset is, take a look at this quote. This comes directly from a senior Cambridge examiner. They said, "The difference between a B and an A in mathematics often comes down to how well you understand 4.4 Newton's laws, motion on inclined planes." Wow, that is a massive, powerful statement. Think about what that actually means for you, sitting in that exam hall. This specific mechanics topic is quite literally the ultimate gatekeeper for those top grades. It's not just about memorizing a few equations and hoping the right numbers fall into your lap. It is a high-stakes test of your ability to synthesize trigonometry, algebra, and physics into one cohesive, unbreakable argument. If you can conquer the inclined plane, you prove to the examiner without a shadow of a doubt that you have the deep analytical rigor required for an A-star.
Okay, let's dive right into this. We have a packed session ahead, and we are going to use what I like to call the examiner's playbook. First up, we're going to unpack the core principles. Second, we'll master the method mark strategy. And third, we're going to reveal the top examiner warnings. Let's get started.
Section 1. The core principles. Listen closely here, because I need you to completely abandon the idea that rote memorization is going to get you through paper 4 mechanics. Here is the secret that most students never realize. Examiners actually grade your mind, not just your paper. Memorizing formulas? Well, going back to our culinary analogy, that's just like buying a really fancy set of chef's knives. It's a great start, sure, but it definitely doesn't mean you actually know how to cook a meal. The examiners are assessing what are officially known as cognitive domains, and these are distinct levels of assessment targeting your knowledge and understanding, your real-time application, and your critical analysis. So when you open that paper and see a question about a 5-kilogram block resting on a rough plane inclined at 30 degrees, the examiner isn't just looking for your final numerical answer at the bottom of the page. They want to see your foundational knowledge of the forces involved. They want to see your flawless application of Newton's second law. And most importantly, they want to see your critical analysis in how you resolve those forces parallel and perpendicular to that plane. They are actively measuring your analytical depth, not just your superficial breadth.
So, to actually hit those highest cognitive domains and secure the top marks, your answers have to clearly demonstrate 3 specific things. First up, causal relationships. You have to show you understand cause and effect. For example, recognizing that an increase in the angle of inclination causes a decrease in the normal reaction, which then directly causes a decrease in the maximum possible frictional force. You have to trace that logic step by step. Second, precise definitions. You absolutely cannot confuse the coefficient of friction with the actual frictional force. It sounds basic, but under exam pressure, it happens all the time. And third, integration with other syllabus areas. The principal examiner reports explicitly state that candidates who reference cross-topic connections achieve significantly higher marks. This means flawlessly integrating your calculus, if the acceleration happens to be variable, or bringing in your pure math trigonometry skills to resolve forces quickly and efficiently. Whether you're pulling from foundational knowledge in Syllabus 580, 0606, 4024, 4037, or 4040, integrating these concepts proves to the examiner that you see the entire mathematical picture, not just isolated topics.
All right, let's move right along to Section 2, the method mark strategy. This is where we take all that lovely theory and translate it into an absolute airtight exam technique.
In Cambridge Mechanics, the actual process of cooking your data is what earns you the points. Let me be very clear. You can have the completely correct final answer, but if you don't show the correct logical method to get there, you are going to walk away with almost 0 marks. On the flip side, you can make a really silly arithmetic error on the very last line of your calculation, but if your underlying method is flawless, you will still secure the vast majority of the marks. So the absolute crucial takeaway here is this.
Process equals points. Your presentation and your adherence to strict mathematical conventions are totally non-negotiable. What does that mean in practice? It means drawing a large, incredibly clear force diagram at the start of every single inclined plane question. It means using proper headings, literally writing out resolving forces parallel to the plane before you even start writing your equations. Because if an examiner has to sit there and guess what your messy string of numbers actually represents, you have already lost the psychological battle with them, and you very likely lost the method marks too.
To guarantee you capture every single one of those method marks, you must use a rigorous 5-step procedural framework. Now, you might have heard of the PEEL framework, Point Evidence Explanation Link, used in essay writing. Well, we are going to adapt that specifically for mathematics. Here is how it works. Step 1, deconstruct the question. You need to decode those specific command words. What exactly are they asking you to do? Step 2, extract the data. Pull the mass, the coefficient of friction, the angle directly from the text and put them straight onto your large clear diagram. This right here is your evidence. Step 3, select the framework. Ask yourself, are we using F equals ma, or are we equating forces to 0 because it's in equilibrium? Deciding this is your point. Step 4, execute the notation. Write down your algebraic equations clearly, substituting your data in step by step. This is your explanation, showing the examiner your exact thought process. And finally, step 5, present terminology. Solve the equation and state the final answer with the correct units and to the correct significant figures. This perfectly closes the loop and acts as your link.
Now, mastering procedural frameworks exactly like this one takes real consistent practice. So before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Go ahead, click that subscribe button and hit the bell icon right now. You really don't want to miss out on these weekly, vital, grade-boosting strategies.
All right, now it is time to put everything we've just talked about to the test in an interactive workshop, Finding the Flaws. Get your analytical brains ready.
We are going to look at a classic past paper question. I want you to evaluate 2 student archetypes we see all the time, Alex and Sam. Now, both of these students studied hard. They know their stuff across multiple syllabuses, whether it's 0580, 0606, or 9709, but right now, both of them are losing massive points on this inclined plane question. Take a really close look at their answers side by side. I'm going to give you a moment to scan the data. Can you spot exactly why their methods are failing the PEEL framework? Take a few more seconds, really look at the structuring. All right, time's up. Let's break this down together. On the left, we have Alex. Now, Alex overloads the page with raw math facts, but provides absolutely zero context. Look at it. There's a massive block of numbers, but there is no force diagram whatsoever, and there is no clear introductory statement of F equals ma. Alex has all the right ingredients, but they are literally just thrown on the kitchen floor. The examiner cannot follow the recipe. Then, on the right, we have Sam. Sam has a beautiful, clear diagram, but Sam rushes the execution and completely misses the specific command word requirements. The question explicitly stated, show that the acceleration is exactly 2.5 meters per second squared. But what did Sam do? Sam used decimals throughout the entire calculation, rounded way too early, and ended up with an answer of 2.49. Sam ignored the crucial word exactly and totally failed to use exact surd forms during the working out. Both Alex and Sam fundamentally failed the method mark strategy. Don't be an Alex, and please don't be a Sam. And hey, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's move into Section 3, Top Examiner Warnings. What we're looking at next is the exclusive behind-the-scenes intel pulled directly from the principal examiner reports.
Reading through years of these reports highlights something fascinating. There are exactly 3 classic, repetitive mistakes that consistently, year after year, block students from getting an A* in Topic 4.4. And listen to me, these aren't just minor calculation slip-ups. These are fundamental flaws in execution that scream to the examiner that the candidate doesn't truly understand the physical system they are attempting to model. When we actually break down the hard data from the examiners, it is incredibly revealing. A massive 40% of all lost marks in this topic come from vague answers. What does that mean? It means students are just writing down floating equations without ever defining what the variables actually are in relation to their diagram. Then, 35% of errors stem from missing context. This is a classic trap. This happens when a student memorizes a formula perfectly, but applies it in the completely wrong direction because they didn't contextualize the physical scenario. They didn't pause to figure out whether the object was on the verge of sliding up the plane or sliding down the plane.
that changes the direction of friction entirely. Finally, 25% of the lost marks are simply due to poor presentation. This means skipping crucial algebraic steps in your working, having illegible handwriting, or just failing to clearly separate your perpendicular and parallel resolutions on the page. The examiners literally cannot award you method marks if they physically cannot follow your mathematical narrative. It's that simple.
Now, this right here is the ultimate examiner alert. The most common critical mistake is providing a generic theoretical answer rather than a context-specific scenario link. Let's say the exam question asks about a car driving up a steep hill. Your equation on the page shouldn't just be the generic formula, P minus F equals ma. That is not enough for an A-star. It needs to be the specific driving force derived from the power provided, minus the specific component of the car's weight acting down the plane, minus the specific air resistance mentioned in the text, equals the specific mass times the acceleration. You see the difference? Always, always link every single point, every single variable, and every single equation directly back to the unique physical scenario given in the prompt. You have to make the math fit the story they are telling.
So to truly secure that top grade, top-scoring candidates don't just calculate. They demonstrate higher-order evaluative thinking. This is how you elevate your final plating of the mathematical answer to Michelin star quality. When you're reviewing your work, you need to mentally evaluate alternatives. Ask yourself, could I have solved this more efficiently using the work-energy principle instead of applying Newton's laws? You need to question your assumptions. Wait, did I automatically assume the plane was smooth out of habit when the question actually stated it was rough? Consider different mathematical perspectives. And most importantly, justify your decisions on the page with clear, undeniable mathematical evidence. This critical analysis framework, where you consciously move from just being descriptive to being analytical and finally to being evaluative, is exactly what transforms a perfectly fine, average answer into an absolutely outstanding one.
This is the ultimate system, decoding the command words, applying our modified mathematics PL framework, and utilizing a strict time management matrix during your exam. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.
I want to leave you with one final, provocative thought as you prepare to tackle your next set of challenging past papers. Before you put down your pen, sit back and declare an answer completely finished. I want you to look at your page and ask yourself, are your assumptions completely 100% context-specific to the exact inclined plane scenario in front of you? And have you clearly, undeniably justified your analytical framework to the examiner reading it? Because if you can confidently answer yes to those questions every single time, that A-star is entirely within your reach. Keep practicing, stay rigorous with your methods, and we'll see you in the next explainer.